My name is Janice Lally, and I'm the Curator of Academic and Public Programs at the Lawrence Wilson Art Gallery. Today it's a pleasure to welcome you, and at the outset to acknowledge that we're on Whadjuk Noongar Budja. It's land that's never been ceded, and we also acknowledge with great respect elders past, present and emerging. This is part of the Ocean Project 2024. It's a STEAM, Science, Technology, Engineering, Art and Mathematics themed collaboration. It's at the Lawrence Wilson Art Gallery, the School of Design at UWA, and here a CSIRO environment located at the Indian Ocean Marine Research Centre. And we've got partner schools and colleges who are not here today, but we'll be able to send this as a document to them to use for their research. It's bringing together science and art to highlight and communicate research and complex issues related to the ocean. And this is the UN Decade of the Ocean. So stage one is this project, the event, a panel discussion, challenges in ocean research, and the question, how might art help? There's a panel of researchers today, including internationally renowned Dr. Beth Fulton, who is a research group leader at CSIRO Oceans and Atmosphere in Hobart, Tasmania. And together with our UWA-based Dr. Fabio Boschetti and Dr. Matt Andriotta of the CSIRO Environment. And they will discuss challenges that face the marine environment. Following today, there's a stage two of the partnership, which is an artwork commission on this theme, which is funded by the Friends of the Lawrence Wilson Art Gallery. And I have to say I'm so lucky that we have today the president and the membership treasurer here in the second row who were, along with their Friends committee, committed to the idea of students learning about ocean issues through the conduit of art, and were very supportive of this as an education project. And they've funded the Artists Commission. Stage three is when the students have done their work in their own research and any related research that we've passed on to them, and their work will be exhibited in the Lawrence Wilson Art Gallery. I forgot to mention that the Artists Commission work will appear in July, August as part of our exhibition program within the Schenberg Room at the Lawrence Wilson Gallery, and there will be a public event at that time when the artist will be in conversation with our scientists who've been her collaborative partners in the artwork. So sincere thanks to all of the presenters today and for the effort of my colleague, particularly Anthony Kelly and Lyle Branson, who dropped us off here with some equipment, and Guillermo out the front at Indian Ocean Research, who mines this theatre and has really been fantastic in assisting us to get the day working. And so over to Dr. Matt Andriotta, who will briefly introduce the notions of social and cognitive psychology within this context. Matt will then pass on to our keynote speaker, Dr. Beth Fulton, and following her presentation, we'll come back to a few questions from the audience with the pleasure to introduce you to Kirsten Hudson, our artist. So over to you, Matt.
Hi, everyone. Janice kind of introduced this portion of the talk with quite a bit of grandeur. I'm not going to so much go over theory here as just get you to reflect on your own thoughts. So without being too confrontational, I just want to ask, like, why are you here? You know, what brought you to this talk? Was it that, are you here to support the art gallery? Are you here for Janice? Are you here because a colleague dragged you along? Or maybe you care about the ocean, protecting it? Maybe you're interested in ocean research, or believe Beth, who will be talking in a moment, has something very useful to say. And if that's the case, like, need to kind of reflect on what exactly the ocean is. What the ocean is will characterize like how we think about arts and how we think about science in this domain. So is ocean a kind of extension of nature for you? Is it just part of nature? Is it a place which gives us seafood, fish? Is it a place to share kind of intimate experiences, diving, going to the beach, that kind of thing. When you think about the ocean, what exactly is it that you think of? What comes to mind? The other question I'd like to get you all to reflect on before Beth starts talking about the ocean and its future is, when is the future? These kind of timeframes are very important for when we make predictions and how much certainty we can have, and what priorities we might have. So is the future an hour when you walk out of this room? Is it in a week? Is it later this year, later this decade or century? Is it 10,000 years from now? What kind of future are you interested in? I suppose it's just my questions to you. What is your priorities? So I'll pass you over now to Dr. Beth Fulton, who will talk a bit about scientific research in this area and share a lot of valuable insights.
Cool, thank you. I'll just quickly share my screen. So I pay my own respects to the various elders of the lands that we live on and the sea countries that we touch on. They have a very deep connection to the sea country and to the future and the past of it. And I think they also have a deep appreciation for the kinds of change we're going to experience over the next couple of decades, as they're the one culture on Earth that has continuing stories from the last time the planet saw this amount of climate change so quickly in the next couple of decades, having lived through the last interglacial. The ocean is a big part of that story about the future, and that's because the 75% of the area of the world is still covered by water as the ocean. Now, that's a statistics most people appreciate, but it's a very thin layer. So if you take all of the ocean water and you made it a solid bubble, it's that blue bubble that I've got sitting on Australia there. So while it does cover a lot of area, and it is 97% of all the water on the planet, it's actually a fairly small thing. It's like a thin blanket that covers that. But that thin blanket still produces 50 to 80% of the oxygen. So the phytoplankton and things that live in it produce the oxygen in the atmosphere. Now, a lot of that oxygen actually gets used in the ocean by species I'll talk about in a second. But the water, that blanket that it forms, means that we can't actually know exactly what's happening on the bottom of the ocean floor. It's not like Mars, where you can see directly to the planet. It's still true that we know more about Earth, Mars and the moon in that kind of direct observation than we know about the Earth. We do research the bottom of the ocean quite a lot, but we do that often by either sending robots down or by inference. So using mathematics to understand how the ocean blanket bumps up over deep sea mountain chains and into deep sea troughs, we infer where those mountain chains are, which means that periodically we get very big surprises. So only about 8 or 9 years ago, we suddenly discovered 5,000 new undersea mountains that we didn't know about before. And they were really close by. Like there was one that was only 150 kilometres off Sydney. So we still get many surprises out of our oceans. Now, I said before that most of the oxygen that we produce in the ocean gets used in the ocean, because 75% of all animals on the planet still live in the ocean. We are actually an oceanic planet, and big things like the Great Australian Barrier Reef, can actually still be seen from space. You can not only see individual reefs as you fly over it, it is actually a body that you can see from space. And there's a huge diversity of animals that live in the ocean, from the largest single individuals on the planet, such as the blue whale, which visits not only Western and South Australia, but many places around Australia, down to the very smallest of viruses. And these are viruses actually attacking a bacteria there. We have some of the oddest animals on the planet that live in the deep ocean, because basically when you're living that far down, there's not too many other things around you. So anything you find, you either have to try and reproduce with or eat, which is why we get these really funny shapes, like this huge eel-like animal with its mouth. We also have some of the oldest animals on the planet inside the ocean. So tiny little jellyfish-like animals called ctenophores that have been around for 700 million years. And some of the cephalopods like the nautilus and stuff that have been around for hundreds of millions of years. So it is quite a diverse place. Now, if we think about a human interaction with the ocean, most of us think about fishing. It's a very traditional use of the ocean, it's one that many of us are linked to. But the reality of what interacts with the ocean now is radically different. These are all actual pictures of things to do with the ocean. And I don't know about any of you guys, but that a picture of the Chinese beach is not exactly my ideal image of how to interact with the ocean. There's still a lot of people there for my autistic mind to get around. But it is a fair representation of what's happening. So if you can think of everything that's happened on land over the last 10 to 20,000 years, we're now doing that in the ocean. So many of you may have heard of the agrarian revolution, which is where we got agriculture on land, the industrial revolution, when, we got coal-fired power stations and steam engines and all of those kind of things happening. And then the great acceleration that happened after World War II and took off. That's all happening at once in the oceans, and we've got really exponential increase in the use of the oceans. But the reality is, if we're going to feed the 9 to 10 billion or more people that are going to be on the planet into the future, the oceans are going to be a big part of that, and also a big part of the decarbonisation of all of our supply chains. Now, if we look at Australia, it's got the third largest exclusive economic zone in the world, and that's the patch of ocean around Australia where we don't necessarily own it. You only own out to 12 nautical miles, but we have oversight of the economic activities that happen in that zone. And it has many products and activities that happen there, but also a very unique ecology. I would also point out that that ocean area is larger than our land mass. So while we're very dispersed as a people on land, if we think about population density, it's even more so when we think about the ocean. Now, one of the tricky parts is that you think, okay, oceans are the same everywhere. Well, unfortunately, that's not the case. Oceans are very different in different parts of the world, and particularly around Australia, because we're the only continent in the world that has 2 tropical currents going down either side. So every other continent on the planet has at least one side where they have what's called an upwelling, where very deep cold water from the deep ocean that's very nutrient rich comes to the surface and supports a lot of phytoplankton. Equally, there's a lot of production in places like the Baltic, which is enclosed by human uses and actually gets quite a lot of nutrient pollution. But so the most productive areas of the world naturally are the big upwelling systems of South America, South Africa, and the California. Now, if we think of how Australia compares to that, and we have one of those huge earth balls as the productivity is one of those upwellings. Well, the productivity of the open ocean is tiny compared to that. So you can see there's kind of different sized balls here on the page. Australia's coasts are almost like the open ocean. They're really poor. It's like we live in an ocean desert, much as we live on a landmass that's largely desert. And that's because the area is so old that the nutrients don't come off the land. And we don't get any nutrients from the deep ocean. And we only have some very small upwellings, which means our ecosystems are also very different. So most of the world fish, what we would normally call a fish as just a person on the street with the fins that we eat, they dominate ecosystems everywhere else in the world. In Australia, crustaceans, invertebrates, particularly jellyfish, crustaceans, and cephalopods dominate a lot of the same roles, either that or chondrichthyans. So that's skates, rays, and sharks. We have a very different makeup to our ecosystems in other parts of the world. So some of the lessons that we have from the other parts of the world don't necessarily work very well here. What we do have a lot of is potentially renewable energy. So if you look at tidal energy, now the size of tides around Australia, we have some really high ones, particularly off northern Australia. We also have a lot of wave energy across southern Australia, and wind in Australia is really quite high because of where we sit in the global wind patterns. And the kind of saying goes that the absolute worst day in Australia for offshore wind is better than the best day anywhere else in the world, which actually means that we have quite a high volume, way more production potential than all of our coal mines and other energy sources put together. And it's distributed around the coast. So you've got where you haven't got wind, you've got tidal, but you've really got high wind and wave through most areas. So it is a huge resource, which is why the federal government, amongst others, is looking at it. but that does open a conversation of what we do want in our oceans. And that's because the ocean economy, so the concept of the blue economy, which is the marine industries, but hopefully done in such a way that they're sustainable and have minimal input. So at the present moment, if we just think of marine industries in total and skip over the sustainability part, which I'll come back to, they're currently $118 billion and growing. So that's quite a large contribution to the Australian economy. It's dominated by energy and tourism and represents about 462,000 jobs. And that's really fast growing. So if we dial it back just a decade ago, it was less than half of that. So it's growing really fast. Now, how does that sit through the rest versus the rest of the economy? So prior to COVID, it was actually larger than any one of these: agriculture, coal mining, metal production or construction. But the COVID-inspired and other booms that have happened in construction and metal production in particular mean that they are now slightly bigger than that blue economy. But you can see that it's on the order of coal mining, agriculture, and some of those other industries that we think of as quintessentially Australian. So as much as the media might not necessarily think about the blue aspect to the Australian economy, the marine aspect, it is actually already up there, and it's growing. It's still growing at 10 to 11% a year. And that's true not only in Australia, but around the world. Now, during COVID, a process was run by an Academy of Science related group called Future Earth Australia. So that's a part of a global initiative called Future Earth that's trying to look at what do we really want into the future. So they ran a process in every single state and with traditional owners and asked them what we want, what's wanted. And while different states wanted slightly different things, universally it came back that there's a collective desire to see sustainable, equitable, but knowledge-based use of the ocean. So really resilient coastlines, both in the natural world, but also the human communities living there, given the vast majority of humans in Australia, people in Australia, live around the coast, more than 85%, according to the last census. It's also a very dynamic place and it's constantly changing, and that's something that they want to see true. They don't want it, sort of blocked in such a way that it loses that biodiversity and vibrancy. But they also want to respect the First Nations voice into it, because that connection of land and sea country, there is no division land and sea, it's one country. And that's because they have a very deep connection to it. So back during the last interglacial, and through to 80,000 or so years ago, Australia was connected to Papua New Guinea and was called Sahul in geology. And the Indigenous people that came into Australia at that time travelled around the coastlines before they entered into the centre. So that connection to sea country as an integrated system started, literally tens of thousands of years ago and continues today. It's also a connection across land and sea that all cultures in Australia have. And these are pictures of Bondi Beach separated by a century. So you can see human use of that area has increased quite a lot over that period of time. But it's also under other pressures, such as climate change. And the blue and red stripes there are what's known as the climate stripes. So compared to a specific point in time, a blue line is a colder year and a red line is a hotter year. And you can see it's just getting hotter and hotter. And that's been driven home over the last couple of years, where this is satellite information about the average temperature of the global ocean. Up until about 10 years or so ago, most of these lines sat in the very bottom half of that dashed area, and from there it's been getting hotter and hotter. The orange line was last year, and you can see it sits well above all the previous years, and the black line is this year. So it's exceptionally hot, unprecedentedly hot for our observational records. And that's why you're hearing reports such as the global mass bleaching that's evolved over the last few months, and the very hot footprint that's now happening down the Great Barrier Reef. Now, I haven't got all of the events drawn on this particular map here because it only extended to 2017, though I did drop 2020 on there the other day. I should put 2024 on there as well. But if you look at all of the events that have happened since 2006 around Australia, about 40%, 45% of our coastal habitats are already affected or lost. So you can imagine if you suddenly lost 45% of a land habitat, there'd be a lot of human attention. But because it's under the ocean, people haven't necessarily recognised it. But you can see that effect is all over Australia. And that's because 70% of our marine species are climate sensitive because of where they live or because they're invertebrates and chondrichthyans. Both parts of the ecosystem, both up in the water column, the pelagic part, and the bit across the bottom, the demersal part, have both seen changes. But demersal species are often more heavily impacted because they can't get up and move as easily. They're often tied in place. What we are seeing is novel ecosystem formation. So we're seeing coral reefs form down the coast of New South Wales, but we're also seeing new novel mixes of temperate species, like a temperate fish suddenly living on a coral that's formed in its local habitat, or more likely we're seeing coral reef fish living on temperate reefs that were originally just oysters and rocks, now have these tropical reef species on it. In fact, we had a green turtle outside my office here in Hobart just a few weeks ago. So we're seeing, these species turn up in places you never would have thought of before, and those ecosystems are functioning in ways that we haven't seen before, and they are self-sustaining. If you took all human activity away from them, it's not like we're holding them up as these new species come in. They're forming by themselves as the temperatures change. Now, all of those interconnections between the land, sea, all these new species, all these new uses is a bit mind-boggling. And how do you know when you're connecting to one bit to another what's that going to look like into the future? What impact does it have? It can seem a bit scary, but I'd argue that we're better placed now than any point in history to actually able to deal with that. That's because of work of people like Fabio, myself and others, but also because just generally we have a greater appreciation across all of human knowledge of how those interactions work, and we've learnt from what we've done on land. So we're starting from a higher starting point to try and get those beneficial outcomes. We also have quite a few different knowledge systems working together through citizen science, traditional custodians, as well as Western science. There's a huge diversity of data collection methods, from historical things such as going out and seeing on a boat what's there, through to using DNA, artificial intelligence, satellites and all those kind of things to actually remotely collect the information. Or you can now go and get data collected off the back of a fishing boat or even in the market and figure out how many fish that means there must be in the sea, which is making data collection a lot easier. There's also going to be much more of it into the future, and that's where artificial intelligence is helping us interpret it, because eDNA sits everywhere, and that's when a fish swims to the ocean, it leaves a DNA signature behind. So by having little sensors out there, we're starting to get to a point where we can say what the relative biomass. It can't necessarily give you exact biomass yet, but we can say there's more or less of things out there and know literally what's there, because there's so many hidden things in the ocean that we don't normally see. There's also a brand new set of ways of using the ocean. So some of those are traditional things we've done in land that are moving into the ocean. So, for instance, this is a picture of literally a real picture of an underwater hotel that actually exists. It's an artist's impression of a new means of collecting minerals off the bottom of the seafloor that people are trying to figure out if they can do sustainably or not. And there's literally floating things like floating dairy farm in Rotterdam Harbour that this is a picture of. So some of these activities are old ways of doing things, but in a new location. So this is a hydroponics garden at the bottom of the Adriatic Ocean. And the reason that they did this is they wanted to have pesticide-free and herbicide-free green production that went into the Roman tourism restaurants and stuff. So these divers come down and they maintain these gardens because they don't have any wind or insects coming in. There's actually no pollution footprint there, and there was nothing else happening in this area. It was a pretty shallow sandy bottom, so they're not impacting any habitat. So it was a great way of having a win-win on that front. There's other ways that the ocean use is being recycled and made circular. That's by reusing waste. So if you can imagine the waste from processing a fish that you've caught at sea, that material can go into aquaculture feed. You can reuse infrastructure like old oil rigs as tourism dive sites or hotels, but you can also reuse materials into new clothing and asphalt and other materials so that you're having a lower footprint. So people are really conscious about that repurposing and reusing side of things. But there's also new uses. So electric vehicles like electric ferries are now fairly commonplace in Scandinavian side of things. They're creating new kinds of plastics out of algae. So you could potentially have a pair of shoes like this particular one that's actually made out of algae into the future. Algae is actually a really ubiquitously used material. So anything where you need a smoothing agent, from ice cream to plastics made for using prosthetics in the film industry, or when you're making prosthetic limbs, it's used in foods and drinks, makeup, even in vaccines like remdesivir that was used in COVID, and even welding rods. Algae's in all of those, and not just the stuff that you put on your garden to try and fertilise it. There's other unique kinds of things like backfilling container ships so that they don't go around empty, because the reality is that more than 90%, something like 98%, but definitely more than 90% of all trade in the world is still done by ship. So making sure that that's done in an efficient way is actually a really great way of reducing its carbon footprint. Looking into the future, there's a whole bunch of novel uses that are coming. So like I said, everything we used to do on land is moving into the ocean. Now, in Europe, they've had renewable energy in the ocean for many years now, but that's beginning to open up in Australia as well. And the bottom here is an artist's impression of what a multi-use offshore platform might look like, with aquaculture as well as processing, energy generation, and even an offshore port. So the United States has said that it doesn't have any land capacity to expand its ports anymore. Also, they're worried about terrorist strikes, so it's offshore and a robot based in their case. Then they'd have a lot less of a security concern. So that's something that's being floated for discussion over there. This artist impression did imagine more people involved, and one of Australia's biggest cooperative research centres is bringing industry and science together to see if there's a sustainable way of doing offshore aquaculture and energy generation in Australia, including building it in such a way from the start that it naturally forms habitat that species can inhabit. So by making it the shape of corals and allowing spaces for things to live in and on it. So you're not just imposing infrastructure on the ocean, you're actually working with the ocean to produce habitat that can be left in place afterwards, is one of the key things. And that's where the kinds of work that I get involved in comes in, because while we think of ourselves as thinking man, we're probably more likely on a day-to-day basis like the poor guy in the middle. That's how I often feel. But I have a lot of sympathy for an author called Terry Pratchett, who said that we're actually the storytelling chimp. And that's because we're after realistic solutions. We tell our stories to achieve those rather than necessarily being thinking man. And part of what that involves is trying to translate what the past to connections to the future looks like. And that's because we can't mentally seamlessly go from one to the other like this big artist impression in the middle there. We tell ourselves different stories about the past of a location, the current day or near the current day, and into the future. So part of the role of the Western science that I'm involved in, and Fabio, is making that connection. So thinking under climate change, for instance, we can look at the pathways of how climate affects, say, where we find the fish and how people catch fish. What does that mean for the rest of the ecosystem? The ability to supply markets, the ability for the community to survive through that process, and what might be options to help adapt to climate in such a way that you're still not having a negative effect on the environment. It's still sustainable. Now, some of those, if you think on that was the sort of the left hand, the right hand side, shows that not all of those pathways have a good ending. So no change is going to hit a brick wall, but other pathways might need some development to help get off the land or start later. So that's where you can really get into these different ways of thinking about the future to help you along. And science can help explain what's possible and what's not. So having sat down over the last few years and talked with people about what options they have given the level of climate change and what's happening in the ocean and how to do that sustainably, the human imagination is so vast. They often come up with options that are literally not possible given the laws of physics. So one of my jobs is to actually say, we'll have to wind that one back a bit. It's not actually possible. But using science and particularly mathematical models, which is my particular speciality, we can define what's possible, what's plausible, what's most probable, given the way the world currently is going, say, with policy, but equally help people discuss what's preferable and how to get there. And the reason that I can do that is maths itself is a really universal language of the ocean. And that's because many aspects in the ocean follow mathematical relationships and principles. So it's a really strong language for describing the ocean. And that's not just the living part of that ocean, it's the human use and interaction. So you can mathematically describe the general behaviour of people, how they interact with each other and policy, but definitely on the marine ecosystem side of things. So what we do is we create models of what that world could look like. So from the habitat to the fish population and how humans use that population, how people make decisions about that. You play it and you get the past, which is the grey bit, and you make sure that matches what people have seen and observed and reported. And then you talk through with people what those options for the future of the ocean area is, and you play it forward to see what that would look like. And that's the A to E. Now, those plots can seem a little bit lifeless. So the other thing you can do is work with graphic artists to animate those. So on this one here, climate change is being looked at. The catchment management is under control. There's good sustainable use. There is use of that ocean, but people are on top of the environmental footprint. So it has large megafauna, it has the kind of fish that people want to catch recreationally and that are a good representation of the natural ecosystem there. Whereas on the other side here, catchment management isn't under control. Climate is at the higher end of what's happening. That means that there's quite a lot of undesirable algal growth and microbial mats, disease. It's not the same kind of fish in place in the same way. They're not as desirable. There's no big megafauna still around. There's actually quite a lot of lost death. You can see there's a dead fish at the bottom there, hopefully. The reason the shark stays in the middle is in that particular set of simulations, the sharks seem to do pretty well because they could eat quite a lot of the undesirable parts of the system or the rubbishy parts of the system. They don't always win out, but in that particular case they did. These animations are generated by an artist, but working with scientists and literally come off the back of what the science says. He doesn't put any numbers or images in there that don't come straight out of the mathematical models. So that's another way of interacting around the future of the ocean. So there's a lot to think about in all of I've said, but there's also a lot to think about in the ocean and its future as well. Universally, I haven't heard anyone say that they want an unhealthy ocean. So we really do want healthy ecosystems and a voice into what that looks like, but also knowledge sharing between the different communities and what that is. Thinking about that future isn't easy, so we do need to leverage our connection with the art to do that. But there is a lot of tools to help us marry art and science to achieve that. And adaptation pathways and assessments are one way we can enter in looking into that future of the ocean. So that's a little bit about the ocean facts and what we're thinking about on the science side of the ocean. And just a quick reflection on the connection to art a bit more. The guy on the left there, Richard Levins, is one of the fundamental developers of science models of the kind that I do. And he said that the truth is the intersection of independent lies. And that's because we can't directly know the world. We have to collect it through data and instruments that themselves have some error. So in interpreting that, we're sort of bringing together our little slices of the world to create a picture. But that rings very close to what Pablo Picasso said, that art is a lie that makes us realise the truth. So the two worlds are coming from different directions to actually get a similar view of what's happening. And you can also see that in the way that famous scientists talk about the world. Now, unfortunately, there's no women in this picture because I was grabbing pictures of Nobel Prize winners, and there's not so many women on that side. But all of these guys really recognise the fact that the way that we use language and the way that we ask questions and push at the boundaries of evidence does push us forward in our understanding of the world, right down to the guy on the side there, Brahmagupta, who was the guy that invented zero and brought it to the rest of the world. Now, a lot of his really pushing things, his followers or the scientists who came after him in India about 1,000 years ago actually hid away because they were embarrassed about it. And they said it sounds like more art like in mysticism. But if once you actually get to read it, he was on top of string. It appears he was on top of string theory and stuff hundreds of years before Western science. But the one universal picture, if you read the background or had the pleasure of talking to any of these individuals, some of which have sadly passed away, is that they all had an awe and a wonder. Yes, science can be frustrating and messy, but it also brings you a sense of joy and wonder that's quite equivalent to the way that other people talk about art. And that's reflected in the brain. So when you look at like the MRI and other pictures of the brain, the parts of the brain that light up in a scientist making a new discovery are identical to those in an artist making a new creation. So it is just fundamentally a different set of language for doing the same kind of cognition. You're exploring the world, you're exploring your options, and you're having that deep connection with the world. We just articulate it in a different way. So bringing those two different forms of articulation together, I think, can really help convey both the wonder of what is truly a blue world, but also help us have a conversation about what we want that future of that blue world to look like, because it is going to play a big part. We need to be careful of it to make sure that it continues to sustain us as we go forward. Thank you.
A most incredibly informed presentation. Thank you so much, Beth. I'll thank you more at the end. How special it is to have your presence in this way and your generosity in giving us your time. 2 hours time difference in Hobart, and orienting to this time. It's been very, very valuable, and that wonderful insight at the end where we are really all sparking together with our creativity.
Thank you for that presentation and the questions asked at the beginning. Yes, I'm here for art and science and my grandson doing marine science, but also that beautiful tranquility and sense of us being tiny creatures when we're looking at the sunset over the ocean or in the ocean, that amazing feeling. But Beth, if you used a different criteria when you were looking at scientists' contributions to this, not Nobel Prize winning or whatever it was, what other criteria could bring more women in? Because sometimes the ideas that come from the basement bring about change.
So marine science itself is actually very women dominated. So I sit as a deputy director to the Centre of Marine Socioecology, and where we don't have a pro-women selection policy per se, in the sense of it's a quoted market or anything. It's just the reality that 85% of that centre is women because they're the ones interested in addressing those interconnected issues. So more than 50% of all marine science graduates are women. We do lose some as we go through time with people stopping to have children and stuff, but there is an ever-growing women workforce in the marine space, including in marine engineers and increasingly mathematics as well, but marine science itself. So if you cut to marine science, and particularly if you cut to what they call interdisciplinary, where you've got lots of different disciplines from economics and history and art and science, sort of classical natural science like physics and geology working together, you'd find that women are a very loud voice in that space. But particularly when you get to complicated, complex spaces where there's lots of competing trade-offs and people are caring about the future. It's not to say that men don't care, but whether it's because it's a new area of science or women are just naturally attracted to those interconnected questions, you do see a lot of women in that space, including, so in our centre, the deputy director, myself, and the director, and over half of actually 70% of the leads in our centre are all women. So women can have a big voice into this space.
Thank you.
Thank you very much for this talk. I really enjoyed listening to it. And I have it's a question or like a comment. So I really liked the part where you talked about all the improvements happen over time in some parts of the world. I think that is very important. Also, like thinking about ecological anxiety, I really like this. But still, I do think that like a lot of improvements are feeding on a like growth-based society. feeding a growth-based society. So I want to believe that technology can fix a lot of things, but also I do feel like that it's not really sometimes catching the core of the problem. It's fixing symptoms. And so I'm just wondering if like the transition to technology fixing things is not suddenly like a green or a blue growth-based society. So I think it would be very good to go behind and transition in several different levels of our human being.
Yep, I'd fully agree. So technology will have some role in getting that circularity. That the nature of the blue economy in its truest sense was actually put forward by the cultures of the Pacific Islands, who wanted the green economy, the circular economy, but done in the ocean, because they have traditional cultures there, like an idea called Talanoa, which is open discussion, but also Vanua, which is everything is integrated and you have to be careful of where you step over here because it's going to disturb something else. So they're the people who put forward the idea of the blue economy more than a decade ago in that circular sense. So while all of us see some role for technology in that, it's not going to be the only thing. There does have to be management of footprint. There does have to be consciousness about what seafood you purchase and from where, and how we deal with pollution such as plastics and things like that. So yeah, it's not, technology is not going to save us. Behavioural change will also be a key part of that, and just understanding that the ocean isn't a big dumping area. So for centuries, some European cultures or some voices in European cultures did see the ocean as not only did they not understand it had life in it, I think it was 1880 or something that they still thought there was nothing in the deep ocean. They didn't appreciate it's where most life is. And every time we go out, we still find more species than science had previously known all added together. So we have a lot to learn about the oceans. So that means that we can't just treat as a dumping ground, which they did as recently as just a couple of decades ago. So there will need to be behavioural change. So I completely agree that technology alone isn't going to be enough.
Just wanted to ask, do you feel like you get a more positive response from the general public or people without high levels of scientific literacy when you use illustrations or 3D graphics in conjunction with your research?
Yes. So that's why we do it. Fabio was actually involved when we first started doing this, because we had been working on the northwest shelf of Australia and trying to advise on development there. And they didn't seem to understand what we were saying. They kept making decisions that were opposite to the information we were providing. And I had to give an in-person talk in Perth about 15 years ago, I think it was. And I thought the people there aren't going to want to see these very boring line charts from a mathematician. So all I did was took exactly the same map that I had been showing, and I put stacks of fish, little icons of fish in the number of fish there would have been. So a very simple graphic compared to today. And at the end of that, a very senior public servant of the time came up and said, if you'd ever told me that, I would never have made the decisions I did. And I was thinking, it's exactly what I've been saying, just presented in a different way. So Fabio and I started taking plots out to people and seeing what they could interpret, and they couldn't. The Australian numeracy was so low that they couldn't interpret the kinds of plots that are fairly standard fare in places like Japan. So we started to employ graphic artists more and more to help us create images that people could more intuitively understand, or at least Australians. So that's why we now use quite a lot of imagery to help convey those pictures, because it was brought home to us that we don't speak English as scientists, we speak scientese. We needed to find a way of more effectively communicating, and pictures proved to be that universal language.
Thank you very much for the talk and for organizing this discussion. I'm just wondering, a few years ago, there was a movement around the world. I think it was called March for Science. And one of the concerns in the scientific community was that the public in general might not be listening to us. And some of the conclusions were that, yeah, we might not be willing to get closer to the public community through the ways we communicate. And also sometimes being a scientist myself, it might be seem like I don't know, a little bit of arrogance, not trying to change our ways. Like it feels like a very close community, right? And in the past, I'm not saying it was necessarily better, but some of the early naturalists, their texts were a little bit more like art. Like if you read Alexander Humboldt or even some of the Darwin's work, they were a little bit more approachable and very enjoyable to read. And if you like read scientific papers today, even for us, it takes sometimes years to get used to it. But we are not willing to change that way, actually. Like, and there is a further and further push to make shorter articles or to make more. I'm translating this in Spanish in my head, but more dry text. So it's even harder to communicate now than 10 years ago or 20 years ago. And I think that's pretty much the tendency, even though I know there is like efforts like this discussion panel to try to close those gaps, but we are in a building full of marine scientists and we have a not too full auditorium. So I'm wondering, how can we work on changing that mindset on the scientific community, because might be us who are not willing to get close, right? And surely art is a very good way to try to close these gaps. But we definitely need to find a way to make the scientific community more interested in communicating to the general public.
So I think there's three facets there I'd pick up. I'd certainly agree with you. There's three facets I'd pick up. One, that the kind of formal letters you see in science today, the very stylized writing, was actually very close to the way that they wrote letters originally, like a few hundred years ago when that style became embedded in. So what was a natural communication style then now seems very stylistic to us. And I would agree that I think it should evolve more with the way that it still needs to be interpretable, clear and transparent. But I do agree, I think it needs to evolve to stay culturally relevant. The other aspect is that science is full of very diverse people. Not everybody's in a position to be able to communicate or feel comfortable in communicating in an articulated way, nor do they necessarily have the language skills. So I'm immensely impressed by people such as yourself that can communicate very complex concepts in a language other than their first language. When I try to speak Spanish, I A, sound like I'm two, and B, like I'm Yoda. So my capacity to be as articulate as you in Spanish would be very difficult. But the same applies when you go from science to the general public or into the policy sphere. So Fabio and I also work with a group such as the postdocs we've got involved, but also knowledge brokers. So that they're people who have a deep appreciation for science, but have the communication skills to do that bridge for us, because not every scientist is going to be able to cut out to do that translation in themselves. And not all scientists appreciate that connection. But I think it also goes beyond just science to the public. It's the different kinds of knowledges. So I'm from a generation when I was educated, you were told that there was no quality information in anecdotes or traditional knowledge or citizens' knowledge. Now, that's fundamentally wrong. You just got to do the translation step to go from the knowledge held in those other knowledge types into being able to marry it with scientific knowledge, so that there is value in all of those knowledge types. But that again takes translation skills that not all scientists have. So I think there's a role for art, there's a role for knowledge brokers, and for those scientists who feel comfortable in trying to be a translator, in trying to do that. So Fabio will have seen me give talks where I've completely bombed, and other ones where I've learnt to do a bit better through time. So some scientists like myself are happy to stick it out there, but you're not going to get all scientists to do it, because fundamentally there's quite a large autistic community in the science world, and I have my presentation face as an autistic person, but not all people are able to do that.
Any further questions?
Hi. You mentioned very briefly our relationship with the ocean and Indigenous Australians' relationship with the ocean. I was just curious, I suppose, whether there's any sort of collaboration or outreach with Indigenous leaders and communities to sort of try and gain a deeper understanding into their history and traditions with the ocean, and whether they can be useful in research going forward.
So that's a very rich area. I won't speak to the Western Australian experience. I'm not as familiar with that, but I work with traditional owners along the Great Barrier Reef coastline, where under the Tumras they now have back the control over how those areas are stewarded. So there is a two-way, what they would term a knowledge corridor. So no one knowledge type is privileged over the other. There's knowledge sharing in both directions to help the guidance. So some of the richness that comes around that is what I was referring to, in that the cultures of the Great Barrier Reef, they can remember the formation of the reef, from land to the early brackish estuarine formation to island formation with reefs around that, and then to the true marine conversion. That's trapped in their stories, and there's richness in that stories that they can convey. And we're literally working with them to understand how, as communities, they lived with that degree of change and how rapid it was. So that's one aspect to it. The other aspect is that Australia's been very light on its marine archaeology. So the Western Australia is actually one of the few cases where there's been marine archaeology of in First Nations sites underwater. But there is richness there, and part of trying to communicate that to white fella lawmakers and decision makers, you often hear old greybeards say, well, they can't have been out there 10,000 years ago. It's an ocean. But it was literally land. So that's one way of communicating why they have a connection. But it actually goes beyond that. They don't see a distinction between the two countries. It is one interconnected whole, and that's quite common across traditional owners from all over the Indo-Pacific. So I work in Fiji, the Solomons, Kiribati, Timor-Leste, Indonesia, Southeast Asia, and they all have that interconnected view. And I spend a lot of time with policymakers and audiences trying to explain the idea of integration and why we need to look at all of the drivers and pressures on an ecosystem. But in Fiji, I've just got to say, it's vanua, and they instantaneously know what I mean. And they already, when they have a conversation and a decision about the ocean or land or whatever they're talking about, their little kids are running around them in these. You've got the elders, but you've got little kids. And one of my colleagues once asked why they do that. He wasn't being mean, apart from the fact there was one small child that kept hanging off his head. And it was because they said the little kids pick it up as they talk. And that's because when they make decisions, they make it for 7, 8, 9, 10 generations into the future. But also they think about the connections into the past. So it is a seamless connection. And now trying to get that kind of thinking in Western science has taken decades. Like my whole career has been on that topic. But it's inherent. So there is quite a lot of knowledge to share, both in experiential case of what has been lived through, but just in the attitude to the oceans and how it's connected. It's a much closer representation of what's called the diffusive nature of the ocean. So Western cultures and like the Australian law-making cultures tend to try to box things up like we have on land. There's a paddock for this and you do that in that space and you do that in that space. Oceans don't know about that because oceans do this all the time, both through the water and animals, and the communities that live with oceans recognise that. So they have a lot to give us there. One other aspect that's happening, though, is that we're increasingly also recognising sea country when we're doing surveys. So if you put a survey vessel along Australia's coast now, it's not only just a polite thing to let the traditional owners know that you're moving through their space and potentially have an Indigenous researcher on board. There are protocols what to do when you come across an Indigenous site underwater. Now, that's a fairly recent development. That's only happened in the last few years, but it is a reflection of that evolving relationship between science knowledge and traditional knowledge about what's in the ocean and under it and what it means and the knowledge that can be shared across it. So it's an evolving space, but it's a very rich space on both sides.
Thank you for that. That was really a very, very welcome question, because that's an important asset of this effort we're putting together this year to bring the translation of culture and knowledge in a creative way. Matt, can you take the floor now and take us across your questions, and then we'll invite Kirsten near the end.
Great. I'll keep it quick then. Thank you so much, Beth. Yeah, just I think a running motif through this session has been storytelling and what stories we have about the ocean and where those come from. Some of these stories are very old. Others are emerging. Some of these about the stories we want to tell, such as about how to build the ocean. But the stories we don't have yet are the ones that we will end up telling. And that's what so much of Beth's work explores. There's also this second kind of theme about how we tell those stories. Is it through those kind of dry academic journal articles? Is it through mathematical models, or more kind of visualization and arts? And finally, I just want you to reflect in a moment on the story we tell ourselves, the one we explored at the start of this session. What is the ocean to us? And what is the ocean's future to us? So I'll just leave you with a question to yourself about, has that story changed?
Thank you. Kirsten, would you mind coming forward and just sharing with us, because Kirsten Hudson is our selected artist for the Artwork Commission for Stage 2, and truly it was your proposition why you would like to be part of this project that I think is another layer to why we have art in this question. Kirsten Hudson.
To the friends of the Lawrence Wilson Gallery, because of being able to have this position without their absolute generous donation. So thank you so much for that. Closer, sorry. So I guess if you wanted, did you want me to read out what my proposition was? And then maybe if you like, I can give you maybe a little bit of my own story. So I'll read to you what I wrote, and then I can let you know. Does that sound okay?
Briefly, yeah.
Yep. So I said, I'm fascinated by how our understanding of what it means to be human is evolving. This interest encompasses how the dynamic interplay of nature, technology, science, and culture shapes our understanding of self, others, agency, and connection, as well as what we perceive to be our rightful place in the world. I am particularly intrigued by how the symbiotic turn, this increasing awareness of our interconnection with different life forms, environments, and natural phenomena provokes not only a redefinition of ecosystems incorporating human, non-human, and more than human agents, but also calls for a profound re-evaluation of human stewardship of the planet and the ethical responsibilities that such a role demands. Over the last 20 years, my work has consistently sought to blur and confront and unsettle the lines that divide disciplines, species, self, and other, often dwelling in the liminal spaces and thresholds that both delineate and dismantle these categories. Specifically, I create film, performances, and objects that visually and orally register, perform, or speculate upon human, non-human, and more than human embodiment. My proposed commission aligns closely with these practices and serves as a natural progression for my recent series of experimental animations. These handmade cameraless films all explore in various ways the sublime aesthetics of natural phenomena, experiences that go far beyond human comprehension and elude direct representation, as well as the complex implications of our entwinements with myriad forms of life and matter that compose our shared existence. For me, this commission is an invitation to imagine how the sublime liquid vision and intelligence of the ocean, a philosophical, methodological, and material approach that acknowledges the vast depths of perspective and comprehension available within this ocean's fluid and dynamic breadth, might be harnessed and translated into a cinematic language that is visually, audibly, and emotionally perceptible. And I wonder, what would it mean to merge this sublime liquidity of oceanic becoming with a cameraless film's potential to act as a conduit for expanded ecological consciousness? Could such a material and conceptual fusion deepen our grasp of multi-species interconnectedness and reciprocity? Could it enable an understanding of atmospheric and aquatic phenomena in ways that go beyond mere metaphor? Could it foster a more fluid way of seeing, thinking, and being in the world that expands our human capacity for care, custodianship, and moral obligation? So that was kind of what I've written to get, I suppose, think about this, the role that art might play, what the material practices that can come into play that are inspired by the ocean, not representative of the ocean so much as, I suppose, allow a sense of that experience to be felt through an artwork and the making be informed by the processes and materiality inherent to the ocean itself. I've spent my life growing up on the coast. My family, my dad's family, were deep sea divers in the early 1930s. They were part of pilots that negotiated the harbour. Their family were very poor, and my dad was introduced to yachting and skiffs when he was very young, but they couldn't afford to buy boats, so he learnt how to make them at a very young age. So I've spent the majority of my life growing up and down the coast while my dad sailed, or travelling across the Nullarbor to coasts all around Australia, watching my dad sail and waiting on the shoreline as he left the beach and returned to the beach. So I've spent a huge amount of my time in and on water. Water for me is a saving grace. So this commission offered so many opportunities to explore my own personal experiences, but also, I guess, to capture what I think a lot of people around the world feel about the ocean and how it might, or how art might be utilised as a way to maybe garner more support for the changes that are required in behaviour, changes that are required in mindset. So, yeah. Thank you all very much.
Thank you very much, Kirsten. I think that really takes us to the next stage very well. Thank you all for coming. We're a little bit over time. Thank you, Beth, for your very generous and very informed presentation. I feel quite overwhelmed when I watch it. And then listening to you, I feel excited. For us, Fabio and Matt here, we're going to go forward with a collaboration for the rest of the year, and it's going to have some exciting further opportunities for you to see other stages. Thank you for coming. Thank you, Beth. Thank you, Matt. Thank you, Fabio and Kirsten. Of course, the friends for contributing to this. Say good afternoon now. Thank you.